Coding Train.
All brand new. Learn the
Coding Train, Coding Train.
overarching concepts and some fun stuff too. And with Dan as your guide, come along for the ride on
Coding Train.
Make a crazy pixel mirror to reflect your face. You can make it jump to light speed into outer space. You can generate a maze that can go on for days. You can make your own terrain and some purple rain. You can make a retro game to see how it's done, and then tweak a piece to make it yours for everyone. Make some fractally trees or Twitter bots if you please. And when the seeds are sown, you can make them your own.
Coding Train. Oh, no, I'm looking over there. You're over there. I'll be back in a minute.
Ride the colors of code. You can follow the road to
Coding Train, chuck choo choo, all aboard. Hello, my name is Dan. Welcome to a special Tuesday afternoon edition of the Coding Train here. I am live from Tisch School of the Arts, New York University. I am also saying a special hello to Torch Tech Fair. We are live broadcasting to a screen that's at an NYU, New York University Technology Fair to demonstrate the capabilities of this fine establishment studio with no windows closing in on me. But I missed last Friday, so my regular weekly time for live broadcasts is, yes, I have a worse echo than usual. Okay, there we go. My usual broadcast time is Friday mornings at 10:30 a.m. Eastern time, but I did miss last Friday, so today is a bit of a bonus and a makeup live stream. Although I have to admit, I'm never prepared for these, but I'm really not prepared today. So I'm just going to dive in a minute, but I just want to make sure that everything seems to be working okay. Yeah. So first of all, I have an echo issue in this room in general because this is a very empty, echoey room, and I keep meaning to get some sound foam, which I think will NYU Torch Tech Fair. Somebody write this down. Sound foam. We need some sound foam. You know what? The reason why it's louder, Robin in the Slack chat writes, the mic seems to be louder. But I believe it's louder simply because I started speaking louder, because I was doing a quick streaming test and I was kind of talking like this in a very quiet, subtle way, unlike what I'm doing right now, which is getting a little bit hyped up energy. I'm scratching my nose again, which is a thing that I do as like a nervous tick. Okay, so everything seems to be working. I see some YouTube chat going. I see some Slack chat going. What I did forget to do was tweet that this was happening, and I get a lot of people complaining that they miss because they have notifications turned on to the Coding Train's Twitter account, which I'm going to go to here, twitter.com/thecodingtrain. Am I logged into that account by any chance? I am logged into that account. Here we go. We are going to live tweet the live broadcast. Here we go. So I'm going to go here. And I'm going to see live right now. HTTP youtube.com/user/Schiffman/live train rainbow happy. I don't know which one of these is appropriate. This one seems pretty good. Okay. Oh, that's a little weird. Maybe not. Maybe I'm just going to leave it alone. Do you know what's interesting, though? I think if I do this, there we go. I don't know. Here we go. Just do this. And there we go. You know, Robin in the chat also mentions about the mic that, yes, I could, never mind, I'll get back to you later. Okay, so here we go. So I tweeted, but what I need to do also, just really quickly, I'm going to do this from my phone, is retweet. It's a thing. This is like riveting. Everyone's like, guess what? I signed on to YouTube to watch a live broadcast about coding, and then I just saw somebody operating their multiple Twitter accounts. I really don't want to look at Twitter because I don't want to know what's happening in the news. So if I go to the coding train, I can really quickly retweet that. Okay, wow, it's already been retweeted twice. I can like it, I could reply to it. Okay, I'm off. This phone, the coding train phone, is going to the corner. Now, what I like to do at the beginning of every coding train episode is read a little quiet bedtime story to those of you. I know a lot of people tune in from other parts of the world where instead of being 1:40 p.m., perhaps it's just about 11 p.m. or 2 a.m. So I'm open to page 388, and I'm going to read some random digits to you. 47,716, 30,863, 52,652, 37,079, 86,010, 35,604, 55,373, 34,759, 34,032, and 17,468. Those are today's coding train numbers, brought to you by the number 58,014. Coding train also brought to you by tea. It's warm and delicious. Okay, I should be more dramatic, I'm being told. Next time. Okay, putting the book away. So what's happening today? I have a bunch of things I want to do. And I have this new thing. This is a Google document. Whoa, look, there's people in this Google document. If you can screen cap this link, I bet you can get to it. This is a list of things. This is what I meant to do last Friday. Today is, what is today? Tuesday, February 7th, and we're at about 1:30 p.m. The other thing that I'm hoping to do is show work from the community more. And I don't really have a good system of doing this, but I'm working on that. But we can see here that Guillaume has added a random walker example. Let's take a look at this random walker example. So this is really a nice, excellent demonstration of taking one of my examples and kind of going further with it. Let's read a little bit about this. Each time the walker eats food. Okay, so look at this. This to me looks like, I'm just going to try to guess what this is doing on the fly. And then we'll find the GitHub repository, make sure that link is in this video's description. So this is a random walker, just like the random walker I built in a live stream a couple weeks ago. It looks like, in addition to the random walker, in this canvas, there are a lot of green dots. And I'm assuming those green dots are food. So the random walker is walking around, and every once in a while it encounters food. And then a line is drawn between it and the food previously eaten. So you can see here, this is a visualization of the random walker's path at all the moments where it ate food. And the bottom, a bar graph plots the lengths of the lines, creating a curve which fits a power law. Let's pause this for a second. That is really quite interesting. I can get rid of, meaning that there are most of the time the lines are all of a certain length, and that there are many fewer short lines. And you can see the length of the lines tend to cluster around a common length because the food is some kind of distribution. So it'd be really interesting to see this and what kind of distribution you would get, what kind of patterns you would get if you did something, depending on different arrangements of the food particles perhaps at the beginning. Maybe the random walker moves in a slightly different way, and some of the other variations. So Chris in the chat writes, by the way, on this date in 1997, Next merged with Apple, starting the path to OS X. Interesting little tidbit fact for today. Okay, so that is thank you to Guillaume, if I pronounced your name correctly, Guillaume. I'm looking back. Yes, I think I did. For this wonderful example. You can see it here at this URL. And we'll make sure when this video gets archived that there's a link to it in the description. Wonderful. So I hope to do more of this. I need to figure out a way for people to submit stuff. And I'd like to really show work by a diverse range of people from all parts of the world with different backgrounds and different interests. So, so especially if you are not an experienced programmer who's been doing this for a long time and you're just getting started learning and making something, and please share it with me so I can share it on a future live stream. Okay, now, oh my goodness, what's, okay, I thought I had the permissions to this. This is nuts. Oh, internet. I was pretty sure I had the permission set to comment only or view only. But clearly I did not, because the internet is now trolling me with doing crazy stuff in this document. Okay, I got to shut this down. Hello, hello, secret chat. Everybody, I'm just going to be over here for a minute, going to this document to change the permissions. I should put on some music while I do this, but I think I need to act quickly. What is it? Coding train, next coding train, share. I could have sworn anyone with the link can comment. Off. Anyone with the link can view? All right, I'm just going to turn it off. Okay, I believe everyone's ability to edit that document has now been shut down. Fortunately, people are writing nice, friendly messages in there. And I'm going to now go to view, see revision history, and I will just revert it to back. Okay, so now I have reverted it. I thought I had it. I thought I had a second open document to use as an experiment. Sure, why not? I love that idea. Okay, I'll have a little collaborative document open. We'll see what's on it at the end. Boy, I'm really off topic here. Hello, NYU Torch Tech Fair. Is this what you expected to see? Okay. Coding train collaborative doc. I'm going to do share. And I'm going to get a shareable link. Anyone with the link can edit. I thought I had it, anyone can comment, which I thought I'd be happy to have a bunch of comments. Copy link. And put it in here. So now all of you can screen cap this and retype it if you want, or somebody could put it in the chat maybe. This is a terrible idea, I agree. I'm closing this, and I will come back and look at it later perhaps. Okay, I'm back on this document, and I think I lost probably some useful things that people added, but I'm gonna move on. I'm also standing in the wrong place here, so I'm covering too much of the screen. Okay, so these are some things that I would like to do. And I'm going to close this. I'm going to check the Slack chat. Sorry, Florin Pop. Florin Pop, if you want to put that maze game in the. Oh no. Okay, hold on. Okay, everybody. Yeah, I'll add this to myself. Okay, rows. I'll have to deal with this later. Rows mathematics. Okay. Okay, I got to get started doing something with some code today. And one of the things I wanted, okay, first of all, since I'm going to have to erase this eventually, but a lot of people have asked how this recording studio works. And there's got to be a way that I can get, oh wait, I have an idea. No, I'd have to have it tethered. There's got to be a way, I'm tying my shoe by the way. There's got to be a way that I can get the signal from like the camera on my phone into the live stream as like another camera input. So I'm using Wirecast and a Mac Pro. If anybody has any clever ideas about that, let me know. I can AirPlay. I can AirPlay the phone to Wirecast. I'm not set up to do that right now, but that would certainly work. So as soon as I get a little internal, okay, that's going to work. But what I wanted to just, people have asked how this setup works, and especially since there are folks from this NYU Tech Fair tuning in, I wanted to discuss that briefly. And I would like to make a Medium post or a blog post sort of documenting all the pieces and diagramming it for people who might be interested in doing something similar. So this, basically, what you are seeing, what you are watching right now is being sent from a piece of software called Wirecast to YouTube. Wirecast is commercial software made by a company called Telestream. You can also use openProcessing Studio, otherwise known as OBS. I have used that as well. It works wonderfully well. I just happen to have everything set up and configured in Wirecast, and it has a lot of features that I like to use, some keyboard shortcut things that I need, so that works well. So that's what's being sent out to you. I am also, at the moment, recording to the hard drive of that computer a backup version of this entire video. Now, I have always just recorded to 720p. I am broadcasting 720p, but I'm actually today attempting to record to 1080p. So when the edited versions of videos that come out of today get published, they will be 1080p. We'll see if we're a little worried about the frame rate, but hopefully it'll be okay. So that's what's happening on the computer. Now, how is the computer getting me speaking and an image of me? So I'm in a room. Well, that's me. I'm standing in front of, well, I'm not doing this right now. Right now I'm standing right over here. So I'm standing in front of a whiteboard, and there's a Canon 5D Mark III that's pointed at me. That's the camera that's pointing at me right now. Hello? And that camera is going into the Mac Pro, and Wirecast is currently taking that camera and sending it to YouTube. Now, if I go press a keyboard shortcut on the keyboard, it will switch from this camera to this camera. There's a camera over there, and it is pointed at, I'm not standing there, but me standing in front of a green screen with a laptop in front of me. So the green screen, the feed from this camera is also going to Wirecast. The feed from the laptop is also going to Wirecast. Those two things are being composited live by Wirecast, and then that gets sent to YouTube. So, and then I'm wearing a lav mic, and that's wireless on me, and then there's a receiver connected to the Mac Pro. So the Mac Pro connects to 2 cameras and 1 computer, 3 inputs. Wirecast manages live editing, switching between the various things, and sending those things to YouTube and recording to disk. However, these Canon 5Ds and the laptop aren't natively things that can just be captured by a computer. So they're being sent as HDMI into these Blackmagic Intensity Extreme boxes that then go via Thunderbolt to the Mac Pro. So those are little boxes that live in between. And that's currently how everything is set up. If I come over here and switch back to this camera, now you can see this camera is looking at me. Really what it looks like is, I don't think I have a keyboard shortcut for this. This is exactly what this camera is seeing. There's some lights, obviously. I need to do some better stuff with the lights to get rid of this shadow, but the keying seems to work pretty well anyway. I should mention also that I have a monitor over here where I can see myself and also see the chat. And, you know, there's kind of a problem with that, which is that I often find myself in my videos standing like this, and people are like, why are you looking to the side? And so I would like to get a separate monitor up there, a very large one that I could kind of see preview and also see the chat. Let me ask you guys a question watching this. Let me ask you a question watching this. If I'm looking up like this and talking, does it look like I'm looking up or does it look like I'm looking at you? Maybe if I'm looking over there, maybe this looks more like I'm looking at you and speaking to you. Now I'm actually looking at the camera, which is what I try to do, but if I had a monitor up there, I'd be looking up a little higher all the time. So I'm wondering about that. Okay, YouTube chat is going, I can see. Clearly looking up. Whoa, do I not have the, Mathieu, I wonder if you can check if that delay thing is in the YouTube chat, because I'm noticing it's like the messages are going a little bit nuts. Wow, way too many people are watching this for me to be doing nothing. Okay, I don't want a teleprompter. No teleprompter, please. But it wouldn't hurt to have to be able to see the chat without having to look over here. Okay. All right. So that's a bit of. So here's some things. It's about. Oh God, it's already 2 o'clock. I have till 3:30 maybe. I was gonna say maybe till 4. We'll see how things go. I might have to leave sooner than that. And this is a list of things that I'm thinking about doing. So one thing that has been asked a lot, yeah, Adam in the chat watches. Way too many people are watching, says, way too many people are watching for me to be doing nothing. Isn't that the channel mission statement? Good point. Thank you. Okay, all right, so this is some things that I'm thinking about doing today. And, merchandise, yeah, I'll come back to that later. Okay, Yasu to some folks from Greece that I see are in the chat. Okay, so one thing I want to do is talk about I know what I need to do. I'm going to start with this. This is geared towards beginners and people who happen to be watching a particular playlist. So I need to record and make a video for this particular playlist. So let me go here and let me go to here. So right now, if you are a beginner coming to p5.js and you're coming to my videos to learn about programming in JavaScript and p5.js, and you end up in this playlist, you will watch this introduction, you will go into video 1.2, and then you will discover that somewhere in there I'm explaining to you how to go and download an editor on this page. But you'll notice this editor is not here anymore. The editor, which links here, is deprecated. So you can still download this and use it, but p5.js we're working on, and actually this is another announcement, Medium Processing org. How do I get to Processing's Medium page? Medium, how about this? Medium.com/processing.org. What's the chance of that working? Nope. Search. Processing Fellowships. Foundation report. This is getting close. There we go. Okay. So related to this, I will mention that Cassie Tarkasian is the lead developer of the new editor that we hope to launch publicly soon, which is a web-based editor entirely in the browser. And then eventually, once that's launched, hopefully there'll be some exciting ways we can take that web editor and package it into an app that you could also have as an offline desktop editor. But the original desktop editor had some problems with it in terms of maintaining its cross-platformness, and so we're focusing on this. So my video tutorials, I've been getting this question a lot of like, people are confused because they're total beginners, and the point of coming to this playlist is to, I've never done any of this before. This is all beginner stuff for me. I just want to like learn it, practice it, and then there's this editor in the videos that's not being used. So what I would like to do is make a short video about how to work with p5.js in other how to follow my tutorials with p5.js without the desktop editor. And I'm curious for feedback here from the Slack chat or the YouTube chat. I have a couple videos already. I did one video about working with Sublime Text and a Python server. I did one video working with Atom and a local and using an Atom package for a live server. I was thinking though for this video, and I honestly haven't used it before really at all, I was thinking of demonstrating using brackets as an alternative, and so I was going to suggest people use brackets to follow along with my tutorials. So I'm curious if anyone has any opinions about that, and I would also show, I want the thing that's maybe the most beginner friendly. And yeah, Arendon in the chat mentions, so things like Visual Studio or IntelliSense, these are too sophisticated, I think. So openProcessing.org is also an option that I will mention. Yeah. Right, because of the live preview. That's why I'm thinking of using it. Does the live preview run a server, or does it only, does Visual Studio Code, is that something I don't know what I'm talking about? I just assumed that was like Microsoft Visual Studio. Is that something different? Oh. This is something different. Oh, look at this. Huh. Is this Microsoft's thing? IntelliSense. Whoa, I don't know what this is. This looks very complicated. This looks too fancy. Okay, similar to Atom and Sublime, free. Okay. People are saying, everybody's got their opinion as to the best editor. What I want to know, let me just run through this. I'm going to download brackets, and so I'm going to do this while I'm sorting this out. And let's see what it would take to make your first p5.js project in brackets. Okay, it's a Microsoft open source editor built on top of Electron, made by GitHub for Atom. Whoa! There's also the processing. I'm going to show that as well. I'm going to show the p5.js mode in processing as well. Okay. So let's take a look at brackets real quick. Best is the one you are used to, which I would also have to agree. And for me, that's kind of Atom and running a local server. But I'm curious about brackets, because I think Okay, so I think I now have, okay, I'm copying it. Adam, please share the Google Docs link. Somebody really wants that Google Docs link. You have to go back and, applications, brackets. Yeah, brackets is better for zero complications. Arendun writes in the chat, and I think that is just another text editor, just what we need. Very good point. Okay. Okay, so let's take a look at this. What I want to do now is new. Let's see what the live preview does, by the way, just of this. Yeah, see, this is what I don't like. Oh no, it's running a server. Awesome. So this is perfect. This is what I wanted to use. So this is what I want to use. Now the issue is how I'm going to create a p5.js project. I wonder if does anybody know if Brackets has a system by which you could I guess I could make a package, probably like a p5.js package for it when you made a new project. It would include all the libraries already. But I guess what I'm going to do is just download p5 and use its empty example. So that's what I'm going to do. Okay, so I think I'm good. This is the first video tutorial I'm going to do, which is, I want to come back to this Rose mathematics things. Okay, everybody's gone from my Google Doc that went crazy, and I'm signed out, whatever. Okay, so, yeah. Okay, so, yeah, so people are giving great suggestions in the chat. There are ways I could generate a project using Bower, and I could write a shell script, and there's actually something there's a node package called P5 Manager. But what I want to do is show people how to work in P5. For people who have never seen the terminal, don't know about what running a local server means. So really just the quickest way, if it's your first day writing code, to be able to get an editor, open a project, and play with it. And albeit, this won't be as smooth as having a sort of desktop editor that has all the P5 libraries preloaded, or what eventually will be the web editor. I think this will do for right now. Okay, so here we go. And anybody from NYU in the tech fair actually watching this? Please say hi. I think you've got the Slack chat open there, maybe. So if you are, say hello. Okay. So let me, a lot of people are mentioning Visual Studio, and I will take a look at it. That sounds like actually a great option. It looks like there's a version for a lot of different operating systems, and it looks like it's built on top of Atom. So I will take a look at that, but I think I'll use Brackets for right now, and then I'll take a look at that for another broadcast. Okay. So, so what I'm going to do now is take this out. I want to get a shortcut to Brackets on the desktop. How do I do this? Do they still have that make alias thing? Yes. So let's put that over here. Perfect. And close that. Clean up. And I want that other. I think this is useful. So this is a generic. So what I'm going to do right now is a generic how to use P5 with Brackets tutorial. But I'm going to position it at the beginning as the reason why you might be watching this video is because I'm coming to you from the future. And this laptop is really, I got to figure out a better way to have a second laptop that's not so much blocking the screen. I guess I'm just going to do this. I guess I could lower this a tiny bit. Okay. Okay, it's still blocking. That's fine. A little bit. There we go. Okay, here we go. Oh, and I need p5js.org and the download page. Okay. And you know what I'm going to do is I'm going to put this over here also. And clean up. One problem with me making this video is that I don't know a lot of features of brackets. So what I might do is make the beginning of the video, then pause and poke around a little bit more and see if there's some important things that I should highlight as well. Okay. All right, here we go. Hello, it's me, Dan, coming to you strangely, sort of from the future perhaps. I'm not sure how you found this video, but this video is about how to use p5.js with the brackets code editor. And the reason why I'm making this video is I'm making it, anybody could be watching this and it could be useful, but I'm making it if you are right now a person watching this playlist. If learning to program, learning P5 is completely new to you and you're learning with my materials, you'll notice that in all of these beginner videos, I reference something called the P5.js desktop editor. So that desktop editor is no longer being supported. You can still find it and download it, and in this video I'll actually include a link to where you can download it, but I would suggest that you use a different editor. All of the content, the code, everything should still work and be the same in all of these video tutorials, but you might want to follow along using a different editor. And there are lots of possibilities, and perhaps I'll even make a few different videos showing you different possibilities. But in this particular video, I'm going to show you how to get started from day one with a P5.js project in an editor called Brackets. So Brackets you can find is an open source text editor that knows about the web, and you can find it at brackets.io. And once you're there, all you need to do is download Brackets. It's on version 1.8. I'll have to come to you in the future with like even more. I bet you I have like a lot more gray hair in this video than the previous one you just watched. And then there'll be another one about, you know, this other futuristic editor where I've got my cane or something in here. But anyway, I'm off track here. The point is, Brackets 1.8 is the current version. I already have it downloaded and over here and installed on my computer. So if you want to follow along, pause this video, download it, and then come back. Okay, so I'm just going to launch Brackets and see what happens. So here it comes. So this is Brackets. It's open. Boy, it has a very, very small font size. So one thing I didn't think of is I need to increase the font size. Let's see if I can figure out how to do that. Preferences. So by the way, I just went to Brackets Preferences, and over here I can see there is a little bit of stuff here that looks like I could change stuff about the font size. So I'm going to change that to 36 px. Hopefully you won't need to do that. And then I can get rid of the preferences. Whoops. Can I close the preferences by hitting this X? And now, oops, I don't know what, I've got an extra pane open. Oh boy, I've gone so much for my, stop, pause. Let me just redo that because I don't want to like waste time in this when this gets edited and published. I don't want to waste time with like a whole thing about the preferences. So now I've got this pane stuff. So this is the right pane. How do I get rid of a pane? I knew this would happen. Let me go back to where oh, these are the preferences. No, this is what I need to close. Close, close. Okay, I'm going to quit Brackets. I'm sure you'll be able to edit this together. Okay, so I'm going to go ahead and launch Brackets. And Brackets opens up. And you can see that it opens up with, wait, hold on. I think it's going to open up with this. So let me try one more time. How's that font size, by the way? Alex in the chat writes, hey, future noobs, you guys should use this editor I've never used. I know, it's really, this is, by the way, the subtitle for this channel is Tutorials About Things I Know Nothing About. Okay. So I'm going to go ahead and launch Brackets. And here we go. Brackets is open. And you can see it's kind of opening up with some default. It's probably going to open up with some like getting started project in it for you. And this is something I actually don't care about so much. So really what I want to do is right now open a P5.js project. So how do I get started with the first P5.js project? So once I have Brackets downloaded and I have it open on my computer, the next step that I want to do is go back to the web. Oops, wrong web page. This web page. How about I make the editing really terrible for today? Hold on. The next thing I want to do is go back to the web. This web page here, and I have also opened up p5js.org/download. So this is previously where you would have downloaded that desktop editor I was referring to, and now what I want to do is just download this complete library. So you'll notice here this says p5.js, p5.dom.js, p5sound.js, and an example project. So this comes with a bunch of files which are the individual library files, and those might matter to you to some extent, but for us right now, we don't need that stuff. What we really want is that example project. So if you click that and download it, you're going to get a file called a p5.zip. And I already have it right here. So this is the file that's going to download p5.zip. And now I am going to extract that file. And it appeared right over here. And I'm also just going to open this up here so we can see. So this is really, this folder is the one that I care about the most. This folder is all I ever need for the rest of my time programming and making beautiful P5 sketches. So I'm going to rename it, and I'm going to call it Shipman P5, and then I'm just going to move it onto the desktop so it's its own thing. And you know what? I can even then, just because I'm so confident, I'm going to get rid of that, and I need to minimize this stuff to find that folder on my desktop, which is over here. So this is now my project folder. I'll put it up here in the sky. So this is now a project folder, and it has, what matters in it is that ultimately this sketch.js file, this is where I'm going to write my p5.js code. And what I can do now is I can actually just take this project folder and drag it onto brackets. That didn't work. Come on, brackets, it should work. Let's do this again. Let's try it in a different way. Now what I can do is take this folder and drag it onto brackets. You really can't take a folder drag. It would just be so convenient if it could take a folder drag. Okay, I'll do it a different way. Now what I'm going to do is go back to brackets, and I'm going to go to File, Open Folder. This is important. I want to open folder. I could actually just, I want to open folder. Because I want that whole project folder to be open in brackets. And then I'm going to go to my desktop, and I'm going to click on Shipman P5, which is where I named that folder. I'm going to hit Open, and there it is. So you can see now, it's a little hard to see, but in the corner, up here it shows that, hey, there's my folder, and here are the files in it. I can go into sketch.js. I can add create canvas, 400, 400. I can say background, 0. And I can say ellipse, 200, 200, 50, 50. So I've written my P5 sketch. Here it is. And now here's the exciting thing. Right over here, this little button here, give me a tooltip to say what it is. I believe that is the live preview button. Timeout, 51. Yes, background should be 51. People in the chat are saying that it already was open because I had brackets minimized. Okay. All right, everything. Okay. Everything. Sorry, I paused because I saw these interesting messages in the chat. The folder drag did work, but brackets was minimized. Okay, so that's good to know that the folder drag worked. But I think my method of going file open folder is fine. Okay, thank you, everybody. Thank you for clarifying. Okay. Is this the live preview button? Right? Because when I wanted to go to Window, Navigate, View, where's live preview? File, live preview. For some reason, I feel like this is the live preview button. It is. Okay. So, okay, go away. Okay. All right, back. So over in the top right-hand corner over there is this little like lightning bolt. And this lightning bolt is like a play button in a way. It's called live preview. So what this button is going to do, it's going to take the folder that you have, the code that you're working on, and load it into your default web browser so that you can see the result. So what I'm going to do, and by the way, I could get to this also for File, Live Preview, and you can see this is, I don't know what this is, Alt Command P or Shift Command P or something, some keyboard shortcut. So I'm going to press this over here, and we see that Chrome opened up. and it's taking a moment, and now it loaded that sketch. So here's the result. Now the question you might have is, well, what happens when I want to change some code? So, background should really be 51, not 0, as you all know. And now if I go back to Chrome and hit refresh, maybe that color was too similar. Let's make it something less similar. There we go. So you can see it's actually live updating. So I can actually move this over here, and you can see that even, let me make this a little smaller. Hit 0. Hit save, and then it actually updated. So this is a way that you can work. You can have your code editor with live preview, save, edit, whatever, and then you can also have over here, the actual sketch that you're looking at. So this could be a workflow, and I'm guessing that some of you, especially if you're a beginner to coding and you're looking through my tutorials and now you're suddenly using this new thing called brackets, that there's going to be a lot of questions that come up. So please feel free to ask those questions in the comments, and what I'm going to do is come back perhaps and make another video, just follow up on some of those questions if there are a bunch of confusion points that everybody's hitting in trying to use brackets. Okay, I'm going to pause. So, so I'm going to pause, and what I want to do is figure out, are there any other key features here that I should make sure to show? One thing I want to know is if I can duplicate, save as the whole folder. Right? That's just going to save us. So I think I need to do that through the file system. What does this do? This no split, vertical split, horizontal split. This is like showing little errors, but I think I kind of want to ignore that because it's all like asking me to use strict, which I guess I want to ignore. Where do you get print line statements? I should invert the camera image. So I think the only things I want to show are how to get console statements, which I don't think you can get. Like if I put print frame count here, that's not going to come in the linting, right? Or is there a JavaScript console or anything like that? No, I'm going to need to look at that here. So when it's there. Okay, so I'm going to have to mention how to do that. And then I also want to mention about I want to make version 2 of my project. I'm going to copy the folder. Okay, so this is, so I'm going to come back into this video. It'll get edited together. Thank you, Mathieu. Okay, here we go. Console log in Chrome. Yeah. Okay. So there are 2 important additional features that I should probably show you. For example, I've made my opus, which is this beautiful red background with ellipse. And what I want to do now is make another version of it, another project. I want to base it on this project. So of course, there are all sorts of elaborate methodologies for keeping track of versions of projects and iterating over the history, blah, 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 blah. But here's an easy thing you can do. If I minimize the browser and this, I can actually just take this folder, just copy paste it and say and it actually already renamed it, but I'm going to say shiftmin _ p5.2. So now I have another project. I can go back into brackets and I can go file, open folder, and I can now go and open the other one. And now I have a different, and I can make some changes to this one with a different background. I can go to live preview and we can see. Here we go, there's my new project. So as you go from project to project, what I would probably recommend doing is just duplicating that that project folder which has all the library files and everything you need, and then you can open up that one in brackets and edit its own sketch.js file. And as I go through future p5.js tutorials, you'll see there are lots of different analogous situations of what I'm doing in the desktop editor. You could do exactly the same thing in this particular editor. For example, if you needed, at some point I'll show you, you might want to change something in index.html, then that's just a matter of me going over to this file and editing that file. But for at least these first videos, the only file you need to edit is sketch.js. Now, here's another thing. You're going to see at a certain point, I look at debugging. And one thing that I might want to do is say, okay, well, what if I want to know, is this draw function actually happening? So I want to put some print statements in. I'm going to say print setup function, because I want to see some messages, print draw function. And by the way, this is exactly identical. Print and also console.log do exactly the same thing. So I can say console.log, which is logging a message to the console. And as you'll see in future videos, I use this to check the value of a certain variable to see why something isn't working. Is that color what I think it is? Did I get the data from this web server? There's all these reasons why I might want to log messages to understand how the program is working. So once I run this, where do I see those messages? Well, the only place I can see those messages is in something called the JavaScript console. And Chrome, if you're using the Chrome browser, it has it built into it. And other browsers have this too. And the way I can find it, I know a shortcut, which is like Option-Command-J, but I'm going to show you where it is under View, under Developer, JavaScript console. So this is what I want to find. View, Developer, JavaScript console. If I click on this, then I have my JavaScript console here. And you can see here are the messages. Setup. Had a message once, and then the draw function is getting printed out over and over again. And by the way, Chrome Developer Console is kind of smart. It says like, oh, if it's the same message over and over again, I'm just going to say how many times it's been printed and not keep showing it to you. But if I did something like print console.log the frame count, which is a built-in variable that's counting how many times the frame has executed, and I hit save and go back to the browser, and I hit refresh, we can see here now that frame count is showing up in the console over and over and over again as a new number. Okay, so this is the kind of thing you can do. I can also just close that console by hitting the X, and I can get back to it again through the menu or through a keyboard shortcut. So these are all the pieces you need. You need a place to type your code, brackets sketch.js. You need a way to run that code and send it to the browser, that through the live preview button. And then you need to view the results in the browser and also check the console, which is also the kind of place, by the way, if you're going to have error messages. So if I were to do something like, I'm trying to think of what an error message might be, that if I'm going to misspell background, right? If I misspell background and I go over here and hit refresh, you're going to see that's where I get my error message. Background is not defined because background is not actually a function, it's background. So you also find error messages there. And notice here it's saying sketch.js, line number 7, and over here, what's on line number 7? Background, and I can see I need to change that with an R. Okay, so hopefully this helps you get started with making your p5.js projects using brackets. And let me know again in the comments if there are questions, confusing things. I know that the comment I'm going to get is, but my favorite editor is this, or my favorite editor, this editor is better for this reason. There are lots of editors, lots of ways of viewing the results. Brackets is just one of them. I also have 2 other videos, one that shows you something called Sublime Text, and one that shows the Atom editor, and I'll link to those 2 videos in this video's description for a couple other options as well. And I'm actually going to make a couple more videos showing you a couple other things you could use too. Okay? See you soon, maybe in another video. Okay. If you open, Florin Pop writes in the chat, if you open the Chrome Web Console, it will close the live preview in brackets. I don't know what that means. What does that mean? Oh, you mean it turns off the live updating? How interesting. Okay, so there's a lot of features here, but I think I got the gist of it. Ah, I see. This is like saying whether it's live or not. And if I open the console, oh, it turns that off. Live preview is canceled because the browser's developer tools were opened. Okay. Yeah, people will figure that out. I got the gist of it, right? That was okay. I use F12 and click console to get to the console. I don't like Control-Shift-J. Yeah, lots of people have other strategies. Okay, I'm getting some other. Zombie Brains, how do you zoom like that on your Mac? This is I'll show you guys a tip for everyone. I get this question a lot. If I go to System Preferences, under Accessibility, under Zoom, I have this, use scroll gesture. So I have a control. So if I ever hit control and then a 2-finger scroll on the laptop, I can zoom in and out, which I find really useful for making these tutorials. Okay. All right, so let me go back to my list of things. See how we're doing here. Brackets. is done. Okay, so I was going to do open processing. I think I'll do these each in, maybe I'll do one video with both. I guess I can make short videos. One video with open processing and p5.js editor mode. Okay, so let's go back and let me join this with a coding train account. Oh, wait a second. I guess it doesn't matter. You can type my email here on the screen. Password, I'm not a robot. Stay signed in, join. Okay, so I created a coding train account. I'm going to create a sketch. Great. Oh boy, this is great. So these I can show really, both of these in one video. And then I want to make sure I get, I think I need the more recent version of processing. So let me go and grab that real quick. Yes, I will have fun with my spam. My email's already on the YouTube channel. Come on, download a little faster. I really don't have the music set up or anything today. Let's see. Because I still haven't figured out how to get the Wi-Fi network in here for the soundboard. Oh, this is like still doing stuff. Let's close all this. Soundboard quit unexpectedly. The software barely works. Did Chrome extension time. Okay. I wonder if this is coming through, by the way. You guys will tell me. As always, I always forget the this dot. Is that coming through? I can't hear it. This dot. I'm going to do this dot. I'm going to do this dot. I'm going to do this dot song. This dot. Is it only coming through my mic? Never forget this dot. This dot song. This dot. Okay. Let's close brackets. Let's open up. Let's open up processing. Place. And never forget this dot. I'm going to do this dot song. Never forget this dot. Oops. Somebody compose that song for me. So here we go. Where am I? Yep. Okay. Okay. So what I'm going to show is two other ways. Yeah. What I'm going to do is show two other ways to create p5.js sketches. All right. I would like, if anyone in the chat who is maybe from Turkey could help me with a name pronunciation. Because Sinan, I want to make sure I credit Sinan. And I don't know how to pronounce his last name. I just realized. So this is Sinan. Where's this? Here we go. Sinan Askioglu? How's that? Can anybody help me with that? Askioglu. By the way, everyone should read this interview. And we're going to reference openProcessing. And we are also going to talk about, now, is this already installed? It is. So what I want to do, I actually want to remove it. Remove. Great. Okay. Ashioglu. Okay? Try that. Read it like Ashiolu. Okay, I will try that. Okay, thank you. Thank you for that, everybody. Okay, here we go. Got to keep moving here, everybody. So, let me press some buttons on some cameras so that they don't turn off. And here we go. Okay, here we are. Hello, here's another video about other ways to create p5.js projects other than the now deprecated, out of service, so to speak, p5.js desktop editor. But don't worry, soon, when I have more gray hair, I will be here in a video, hopefully with the creator of what's the upcoming p5.js web editor to show you that and how you can make p5.js project with this new editor that's going to come out soon. But while I'm here in this video, I'm going to show you two wonderful projects made by the Processing Foundation community. And one is called openProcessing. So openProcessing is actually a p5.js web editor. And it's a project that's been around for a while, created by Sinan Ashioglu. And I apologize, Sinan, if I did pronounce your last name correctly. I'm sure I'm going to get lots of comments here about how I botched that. But Sinan originally created openProcessing as a way to share processing sketches, which are Java applets. And he recently launched a new design. I should really have Sinan come in and present this sometime on the channel. And so it's a great way that you can quickly mock up a p5.js sketch in the browser and then have it to share. So the only thing that I've done before making this video is go to openprocessing.org itself and sign up for an account. So I actually signed up I already had an account, but I signed up for a new one just for this YouTube channel called Coding Train. And so once you've signed up for an account and go to your page, you can make a profile and do all that kind of stuff that I'm sure you can figure out. But really what I'm interested in is the fact that making a sketch is as easy as this button, create a sketch. So let's make a sketch, create a sketch. And you can see already I have a code editor here. I have some settings. There probably is a way I can increase the font size, but I'm just going to sort of zoom in on the browser. And we can see there's my sketch. It has an ellipse in it, and I can actually I can hit save, and there it is. Or I can hit run, and there it is, I'm running it. So there's the sketch. I can hit submit, and I can do stuff like change coding, train demo. Description is I am live demoing this on the YouTubes. And how to interact with it, use the mouse, and I can add tags and license and all that sort of stuff. And then I should be able to, where do I submit this? I'm done, right? Fail. This is enough to edit. I have to edit out the fact that I can't figure out how to use this. Where do I submit it? Private? No, I don't want it to be private. I don't want to delete it. I don't want it to be a draft. I'm done. Did I do something wrong? Refresh. I left the page. Save. Yeah. Oh, I forgot about the submit button. Hold on. I am making this on the YouTubes. Mouse, and then hit submit. Oh yeah. So I just did things in a weird order. So let me go back and do that again. From here. Okay. I'm just going to go from So now I have a sketch, and the font's a little small, but I can zoom into it. If you can see, it's a very simple sketch. It just did an automatic template for me. I can obviously add lots of code and do different things. And I can, just to do something, I'm going to change the background to a slightly purplish color. I'm going to play it to see how it looks. And you can see here's my sketch. It's filling the background with one color, and it's drawing a lot of ellipses. How do I get out of this now? There. So I have to go up to the top, and then a little menu appears. And what I want to do is this button looks like this button will go back to the code. So now I'm back to the code. This button will go back to the sketch. Okay. Then I can also hit save, and then I can give it a name like coding train. And I am on the YouTube's train. Choo choo. And then you interact with the mouse. And then all I can do is hit submit. And here we go. I have my coding train p5.js sketch. And I have this link, which I can send to anybody to share so that they can see it and use it as well. So that is a really quick way also to create sketches in the browser through an online site like openProcessing and share those sketches instantly. So that's one. Let me go. I'm just going to do 2 in one video. That's what I'm doing. So another way that you can do p5.js sketches is you can actually go and get Processing. Now, Processing is a project that's been around since 2001. It's a Java-based platform. You do a lot of videos that use Processing, and if you watched my intro to p5.js, I kind of referenced the relationship between Processing and p5.js. They're sibling projects, part of the Processing Foundation. So if you go to processing.org, and you go to download, you can get to a download page where you can download the Processing desktop application for your particular operating system. Now, what this is meant for you to do is then write processing code and run desktop applications. But it so happens that Ben Fry and Fathom Information Design, Ben Fry being one of the creators of Processing, created a mode for the processing editor. So let me open the processing editor. Here it is. So this is what it looks like. And normally would expect you to write your Java code in here, your processing code, and run it and that sort of thing. But over here up in the top right corner, you'll see there's this little box that says Java. And you notice I can switch to Android and Python. Now those won't necessarily be there by default. Those are modes that I've added through this add mode option. They're ways of using processing to write code in a different language for an Android application or for writing your code in Python. I'm going to add another mode. It's going to open up this window, and this is the one that I want. p5.js mode adds a simple editor for p5.js code by Fathom Information Design. So now I'm going to install that. I'm going to wait for it to download. That's the song. It's the downloading song. I'm really excited. There, and now it's ready. And I can hit remove, and now I should be able to go and switch to p5.js. And look at this. It redid my window. It gave me a little setup and draw. I even have an index.html file, and I can say create canvas 400, 400. I can say background 200, 0, 255, and then I can draw a circle here where the mouse is to do my first sketch, and I can hit run, and then it goes to the browser and opens up. And once again here, if I want to look at the results, if I want to see what's happening in the console, just like I showed in my brackets tutorial, if I want to see any print statements, I've got to look at that JavaScript console in the browser. So I can get to that by saying View, Developer, JavaScript console, or I can use a keyboard shortcut to open that up and close it. Okay, so those are 2 other ways that you can make p5.js sketches. You can use the brackets editor, which I showed in a previous video, and in this video I've shown you openProcessing and the processing p5.js mode. So if you have questions or trouble with these things, please write it in the comments, and I look forward to hearing what you end up making, and hopefully you enjoy using these tools. Goodbye. Okay. Okay. Okay, so, YouTube's, right. That is, quick change the number and see what sketch you get. I don't get what that is. Me, I am so me. Okay. How are we doing? It's 2:40. Is anybody still watching this from NYU? It's fun. I don't know if that's been a total like failure, or if there's actually people there watching this, checking out our setup. Okay, so let me close all this stuff, and now I'm going to do some actual coding now. Let me get back to my document, and okay. So there are a bunch of in the URL of openProcessing. I think I closed that already. Oh, you mean you could just like get different random sketches by like trying different random IDs, or have you guys done something cookie and clever? Okay, so I think what I want to do now is, oh wow, somebody's watching from Cyprus. That's amazing. I think what I would like to do is, okay, so I have a bunch of coding challenge possibilities. I was planning to do an attraction repulsion challenge because that I think would be useful and interesting. I was going to do a 3D walker. That was something I was thinking about. I want to fix the Islamic star patterns tutorial sketch because I want to, there's somebody on Twitter I should pull, no matter what, I'll at least pull that up and show it today because I'm going to implement it at some point. I really went off the deep end with that, the way that I implemented that particular tiling pattern. I can use the law of sines, which is a set of trigonometric equation to solve the tiling pattern, the star pattern much more easily. So I want to do that, and I also was interested in doing the rows mathematics thing. Double pendulum simulator, that would be great. I'm not so sure I'm going to be able to do that today. Look, everybody in the chat is writing where they're from. That's lovely and amazing. Okay, so let's do the attraction repulsion. Maybe I'll try to do the attraction repulsion and the rows. Control-Shift-T will open the tab again. You guys really want me to do this, open this? I can also just go here, right? My sketch. No? This one? So change the number, to 80? Just change it to like 80 because somebody made a sketch right after me? And what am I? Oh. Or just try random numbers? Nope. I don't get what I'm supposed to do, but that was interesting. Okay. Wow, hello Pakistan, hello Sweden, hello Hungary, et cetera, et cetera, et cetera. I know, Zombie Brains, I saw, by the way, that you asked for a Chrome extensions tutorial, and I didn't realize, a lot of people were requesting that, and I always said I was going to do it, and I never got to it. And Zombie Brains, I should point out, was incredibly helpful in helping me figure out the lighting and the camera settings for this studio. And so I am going to make a note, especially with that request, to get to that in the next week. But I think that I'm sort of not ready to do that today. But send me a tweet or send me an email, I think, or something. I will really get to that. And I do have some resources that I could also send or post on Twitter of some like write-up and examples that I've made. Okay. Oh, random numbers was indeed the point. Oh, you just like this one. I'm annoying. Oh, random numbers was the point. Okay. All right. Yes. Okay. Okay. So let's go to let's figure out what we're going to do here. Attraction repulsion. Now the other question is processing or P5. I think P5 because I have most of these examples in. So now that I made those video tutorials, I'm going to go and use the Atom editor because that's what I'm used to using. And I've got the star patterns project open. This should work fine though for attraction, repulsion, and let's open this with Atom. And oh, here we go. As always, I always forget the this dot, this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do dot, this dot, this dot, this dot, this dot song. This dot, this dot, this dot. Never forget this dot, this dot, this dot, this dot, this dot song. Things that you know what I'm gonna do also. This dot, never forget this dot. This dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do dot, this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot. Friday is what? Third, fourth, fifth, sixth. This dot, this dot, this dot. Never forget this dot. This dot, this dot, this dot. Never forget this dot. I'm just trying to remember. This dot, this dot, this dot, this dot song. Chrome extensions is really one reason I'm not sure what to do about it. Is it's gonna kind of take Chrome extensions. There's something I was just thinking of, which is why I went to this document and then I totally forgot. Is it the 8th? 8th. Thank you. Wait, what's today? Today's the 7th. Oh my God. Friday is the 8th, 9th, 10th. Thank you. Okay, I was going to put something there that I was trying to remember for Friday. But anyway, okay. So attraction, repulsion. Okay. And then what I want to do is get terminal open. And attraction, attraction, run a little server, close that. Let's go to Chrome. Boy, I have so many things open in Chrome, this is crazy. What's open here? Why are there like multiple instances of Chrome open? Because one of them was like the live preview. Chrome, new window. And now I want to go to localhost. Okay. This looks good. And
so this is random, this is noise, Perlin noise that is. In the core random algorithm, the actual random algorithm itself, those
I have
numbers
more room to
aren't
work with
related
here.
at all. You pick, like, I'm picking random numbers between 0 and 10. 9,
Okay.
2, 7, 6, 1, 9, 4.
So this is what I'm thinking.
9, 2, 1, 3. I pick 9 a lot apparently. But with Perlin noise, I might pick numbers like this. 2, 3, 4, 3.
This is what I'm thinking. Let me get the eraser over here. So what I'm thinking is, you know, I noticed, this is what happens when I do these extra live streams, by the way, in a Tuesday afternoon. I had a 3-hour class this morning. So I'm a little bit exhausted already. That's why my brain is feel a little brain dead. But what I was thinking would be, so there's gravitational attraction, which I do have some tutorials about. And I was thinking of implementing something where there are attraction points. And I drop particles in, and they're kind of like attracted to these attraction points, you know, and maybe start to spiral around them. I was also thinking of doing something where there's like a single attraction point, and I drop particles in, and they are attracted, but if they get within a certain distance, then they're repelled. So I don't know if there's an interesting visual way to combine both of these. I guess like some of these could be, we could sort of try some combination of this, but this is kind of what I'm thinking about implementing. And the reason is, let's see, Attractors, visualization. Let's see if I can find, oh yeah, but these are like, you know, you can get some, these are strange attractors, and I have a video about the Lorenz stuff. This is not really what I was looking for. Let's see what I get here. Lots of examples. I guess I don't need a visual example to work from. what I'll do is just make it, and then I'll do an intro that shows it at the beginning. Okay, so jam3.com. What is that? Somebody's saying, I hope you guys aren't telling me to go to some website that's going to spam me. Jam3.com. Ooh, look at that. That's cool. Oh yeah, look at that. Wow, this is cool. Fancy. This is like, looks very like 3D, and wow, this is great. Thank you for sharing that. Okay. Okay, so I want to get moving on this because I don't have a lot of time. So I'm going to erase the whiteboard in a second. I'm just pressing some camera buttons. I'm going to try to I'm erasing the whiteboard, I'm erasing the whiteboard, I'm erasing the whiteboard. Yeah, if only I could sing. What a life, huh? I really can't, it's terrible. What's going on over here? That's white. This camera got a little bit out of whack. Turn it a little bit this way, there we go. Sing and paint. If I could sing, if I could paint, I could just, I don't know, live in the sunflower fields and record music and paint beautiful pictures. Instead, I'm in a room with no windows that echoes and starting to get warmer and warmer and warmer in here. Even though these are LED lights and they're not supposed to get hot. I'm starting to feel a little hot. Okay, let's get this started. So what I'm going to do, I don't know if Mathieu is tuning in, but what I'm going to do is I am going to do the thing where I'm going to show it at the end, and then so I'm not going to worry about doing a kind of intro to the coding challenge right now. I'm just going to launch right into it. Now, okay, so here we go. I haven't been using the train whistle today because I'm having a lot of self-doubt when it comes to the train whistle. That's how I feel about the train whistle. Okay. It's ginger tea, okay? Ginger tea. That's all it is. Okay. Here we go. All right, I won't worry about the whistle right now. Okay. All right, let's get started. So actually, let me come over to the whiteboard. The first thing that I need to do, basically, this is what I need for this example. I want to have two kinds of objects in my world. I want to have something that is an attractor object. And honestly, I don't think I need a full-on attractor object in this case. The attractor can actually just be a single vector, right? All I care about for the attractor is its XY location, where it is. So I want to have an attractor, that's a thing that's drawn on the screen, and then I want to have particles. So I want a single particle which is like a dot, and I want that dot to be attracted to the attractor. And how do I want it to be attracted to the attractor? By using gravitational attraction. So the formula for gravitational attraction is the force of gravity, expressed as a vector, is equal to g, which is the universal gravitational constant, the gravitational constant. The universal gravitational constant, g, times the mass of one object times the mass of another object divided by distance squared. The truth of the matter is, I think I could consider the mass of this particle as 1 and the mass of this attractor as 1. So if the mass of both of these are 1, then my formula becomes g divided by distance squared. So really the force of gravity, I'm 1 with the force is 1 with me, the force 1, something like that. Anyway, the force of gravity is really just a constant that we're going to make up. Is it strong or is it weak? I mean, this is a real number in the real world in physics, but we're living in this fake pixel space, so I'm just going to make up g. And then we have this interesting question of, should the force's strength be proportional or inversely proportional in distance. So what this means is if the particle is really close to the attractor, it's going to be really attracted to it. If it's far away, that attraction is going to be much weaker because that I'm dividing by the distance squared. So as you maybe make a creative project out of what I'm showing you in this video, you might play with this idea. Maybe it's weaker when it's closer, it's stronger when it's further. Let's just sort of give it a try. And then obviously at some point we could make this force not attraction but repulsion by just multiplying all this by a -1. So anyway, let's go back to the code and start implementing some of this. So here I am with the code, there you are, and I'm going to start writing some code. So I'm going to go over here, and I have I have a particle, I have a separate JavaScript file called particle.js, where I'm going to create a constructor function with a particle, and I'm going to just give it an x and y. So the only thing I'm going to give to the particle when it starts is a location to start, and I'm going to say this.pos equals create vector x comma y. So now I have a particle with a position that's a vector of an x and y. Now, in the main sketch, I'm going to say var attractor, and then I'm going to say attractor equals create vector 200, 200. Now I could make an object for the attractor like I'm doing with the particle, but right now my attractor is just going to be a thing that stays in one place. Doesn't need to animate, it doesn't need to keep track of a color, so just a single vector is fine. Then I want to see that everything's working, so I'm going to say background 51, and I'm going to draw maybe, let's just use points for simplicity. Stroke 255, stroke weight 4, and I'm going to say point attractor dot x, attractor dot y. And let's just take a look at this real quick. Hit refresh, and there you go. There's my attractor. Oh, the dot in the center of the window. Yes. Okay, so that's working. Now, what I want to do is add a particle. And I want to say a particle equals a new particle, and I'm going to put it at, I don't know, 200 comma 100. And then I want to say something like particle.show. Now, I have a constructor function, so that'll work. I do not have a show function. So right in here, I need to say this.show equals function, and I'm just going to also do the same thing, stroke 255, stroke weight 4, and then point this.pos.x, this.pos.y. Now I realized something I forgot to actually reference the particle itself in the HTML file, the particle.js file, so I'm going to do that real quick. Okay, great. Now, what do I have? I have a particle and I have an attractor. Look at that particle, look at that attractor. Attract the particle. Okay, so I guess I can't do it with motion in my hands. We've got to add some code. So let's go back to the sketch. And what I'm going to do here is I want to say particle attracted to attractor. So I want to have some generic way of saying any given particle can be attracted to some vector. And so I'm going to write a function in the particle object called attracted that receives an attractor. So let's take a look at that. And let's go to the particle. That means I need a function. This.attracted equals function. And that function, I'm going to call it target. So I'm going to give the argument a target. The target is the thing that's attracting it. So we're getting somewhere now. But one thing I realized here is that I don't even have a way for this particle to experience any physics. And so if you're interested in the sort of larger topic of physics engines and the kinds of physics engines you can build, the kinds of physics engines you can use as separate third-party libraries, I've got a lot of videos as part of the Nature of Code course about all the steps, which I will reference in this video. But right now I'm going to do this in a really quick way using something called Euler integration, often mispronounced as Euler, but it's Euler. So what I need to integrate, meaning I'm doing this thing where I'm saying, how does position change over time? This is actually, what's the rate of change of position or the derivative of position? It's this dot velocity, and I'm going to make a vector 0, 0. Then I'm going to make a vector which I'm going to use as acceleration, create a vector 0, 0. And actually, by the way, if you just say create vector with no arguments, it makes a vector 0, 0. What is a vector? If that's not familiar to you, I'll point you to also reference a video that goes over the basics of vectors. So I have position, velocity, and acceleration. Now what I want to do is add a function. Maybe I'll call it update. Could call it step. All physics engines need a sort of moment. You step through time. What is that time? How many cycles of time are you iterating through depending on each frame of animation? I'm doing this in a simple way. Every frame through draw, every frame of animation in my sketch, I add velocity to position, and I add acceleration to velocity. So now, if I were to actually give a velocity 0, 1, and I were to go to the sketch and also say particle.update and run this sketch, we can see, there we go, my particle is moving towards the attractor. Now, I just happen to give it a hard-coded velocity pointed straight at it. So if I go back to the particle and I say something like, -1, 0.2, you can see the particle is moving over it that way now. So the velocity is a vector that controls how that particle moves. I could also give a particular acceleration like 0.01, and you can see now it's accelerating down, right? Because that acceleration is accumulating onto it. So this is a very basic physics engine. I have a particle that has a position, it has a velocity, which is an arrow that tells the position where to go next frame, and I have an acceleration which tells the velocity you should turn, you should slow down, you should speed up, and that's happening here in this update function. Now, if you recall, I said here's this thing called a force, and the force is a vector that is going to, I want to have this particle be attracted to the attractor wherever it is. So I need to calculate a vector that's always pointing from this particle's location towards the attractor. And how do I do that? So the easiest way to get an arrow that points from one position to another position is to subtract those two positions together. So this is where I'm going to start. What I need to do is write in that attract function, I need to figure out this force. There's a bunch of things going on here. So there's three things. One is I need to figure out this force. So I need to know how do I get an arrow that points from the particle to the attractor. Then I need to figure out how big should that arrow be. Is it a weak force? Is it a strong force? The strength of it is coming from this formula that we're kind of working out over here. But beyond that, I'm saying it's a force. And if I come over here, position, velocity, and acceleration, what's the relationship of force to position, velocity, and acceleration? Well, you might be familiar with Isaac Newton, and there's a bunch of laws. I'm sure they're all very important and interesting, but the law that I'm interested in is force equals mass times acceleration. And what did I say about simplifying our world to just make the mass of everything 1? Yeah, so if the mass of this is 1, then really force equals acceleration. So force is a vector that causes a mass. A force is a vector that causes an object with mass to accelerate. And so we can actually just, if I can figure out this attraction force, then I can just put that right into acceleration, and our simulation is going to do exactly what we want it to do, I hope. Okay, so I'm coming back over here. Use the force, I think it's the proper terminology here. Use the force. Okay, now I've lost my train of thought. Okay, so let's put all this stuff back, so to speak, empty vectors. And let's come here. So how do I do this? What did I say? I need a vector that points from the particle's position to the target. The way I get an arrow that points there is I say target minus the particle's position. So I'm going to say var direction equals p5.vector.subtract target minus this dot pos. Now, this is just about the most awkward way I could ever possibly think to write this, but just for the sake of argument, I'm going to put here in the comments, I'm going to put a comment var dir equals this target minus this dot pos. This is really what I want to do, right? I want to say, give me a direction, a vector that points from the position to, Yeah, from the position to the target by subtracting the two positions. But the minus operator doesn't work with vector objects in JavaScript. In other programming environments, you can kind of overload the operators and do fancy things. So what I need to do is use the subtract function that's part of p5.vector, and this will give me a new vector that is a result of target minus position. So now I have a vector that points all the way like this. So the question now is, how big should that vector be? Should it be short? Should it be long? Should it be medium? And there's lots of ways you could decide. I'm going to use this formula. G divided by distance squared. I'm going to consider the mass, so I want to have it inversely proportional to distance. So let's figure out how we can do that. Now, one thing that's nice here is this vector that points all the way from one object to the other, that is the distance. And actually, I can just get distance squared is the direction. That vector, the length of it is distance. And if I want distance squared, there's actually a function, I believe, in P5 called mag_sq for magnitude squared. So this is giving me that value, distance squared, that's on the bottom of our calculation. Now, I also need to figure out what the universal gravitational constant should be. Let's Google the universal I really want to get tickets to the universal gravitational concert. I can't even make my bad joke. So if anyone could get me tickets to those, I'll take Hamilton tickets too, that's fine. So this is the universal gravitational constant. Let's use a little bit of something from that in our code just for fun. So I'm going to say, again, I could just make this up. Var g equals that number. So now the magnitude is g divided by d squared. So I've got a vector pointing from target to, pointing from position to target. I have the distance squared, I have a pretend universal gravitational constant, and now I have the magnitude. So what I need to do is say dir set mag, that magnitude. So what this set mag function does is it takes a vector of any length and keeps its direction, but sets its length to the length that I want to. So I don't like the fact that I'm going to say strength or something, because it's really the strength of the force. And I think this should really be called force, because that's what I'm doing ultimately is I'm calculating this force. So ultimately, I'm starting with a force, that's the full distance, then I'm getting the distance squared, making up a gravitational constant, calculating the strength, and setting it. And now, what do? Acceleration equals force. So in this case, let's take a look and see what we've got. So now, if I call particle attracted, particle update, and particle show, I should calculate a force in the attracted function. That force will go into the acceleration, which will then go into the velocity, which will go into the location, which will update its location, and then we'll draw it. Here we go. And sad trombone. This dot, I'm probably forgetting the this dot somewhere. Okay, let's see what's wrong. Let's console.log the force and see. There's a force that, you know what it is, might be, oh, did I, hold on a sec. There is something showing up here. And did I forget to the order shouldn't matter here, but what did I forget to do? Why not this dot acceleration? Yeah, I should be looking at this chat more. Okay, it is the this dot. Sorry, everybody. Well, Mathieu, you can let me find that in a more quick way, or you can just edit. Oh, okay. This dot. It's always the this dot. This dot acceleration. So let's now run this again. I must be missing something else. This dot acceleration. This dot pause. Let's make this, let's just hard code the strength for a second as 1. Oh, it's working. So there we go. We can see now that it is experiencing that attraction. It's just, I got to really think about the sort of scaling of this. So it's very, very weak Do you see how it's moving just a little bit? Now it's getting closer, so it's going to get stronger and stronger. So this is really like, I got to really start tuning stuff here. And one thing that I'm going to do, I think that's really going to help things a little bit is, one thing I could do is I could just, I want to have a much stronger gravitational constant. But look what happened just there. Whoops, let me run that again. The issue is, boom, explosion. That force was so strong. In the Apollo moon missions where they had to figure out how to go around the moon, calculate the physics properly, and slingshot to get back to Earth. Well, I've got a sort of very extreme version of that happening here. So one thing that I think would be helpful to do is to constrain this distance squared value, because you realize once that particle is so close, the force divided by distance squared is so big that that's just going to spin out of control. So I'm going to say distance squared equals constrain itself between, I'm going to say 25 and 10, what's maybe, I don't know, 400 or something, or 500. So I just don't want, I always want that force to be at play and don't want it to get so big. And now let me do this. So now we can see I now have a particle that's attracted to this particular attractor. And you can see that getting some interesting behavior, but really I've done barely anything yet. But this attraction is working. Okay, so now let's try to do some stuff that's a little bit more interesting. So for example, let me at least give this vector a random velocity to start. And we'll see. So now it actually has a random velocity to start, so it's not pointing directly at it. And the other thing that I want to do, I think, which would be interesting to see, is kind of draw some trails. So I'm going to put background here. And so we're going to see sort of its path a little bit more. So now what we've got is a single particle drawing a path as it kind of orbits this. Now, interestingly enough, another code challenge I wanted today was this rose petal challenge. And strangely, the attraction is giving me this nice kind of oscillating pattern behavior around the actual center itself. Okay, so let's try to be a bit more thoughtful about this. First thing I want to do is I'm trying to decide whether I want to add multiple attractors or multiple particles. But let's add multiple particles first. So let's make an array for the particles. And let's add all those particles to that array. Particles.push, new particle. I'm going to just start them all in the same spot. And then same exact for loop. Oh, I don't need it for the attractor. And I can say var particle equals particles index I. So this is me now having a bunch of particles and having them all do the same thing. And what did I get wrong here? I don't see an error. I don't have a length yet for the particles. That's a good point. Let's see, how many do I want to add? Let's add 50. And we can see there's all my particles all being attracted. They all started with a slightly different initial velocity, so they're all going to have a different pattern. And I think it's so extreme what I'm seeing here, so I want to just draw them with a lot of alpha. And we'll sort of see these paths that they're creating. Okay, so let this run for a little bit. You can see now that I've got something. Everything is really, because of the constraints that I've put in it, everything is and they've all started in the same spot, and their initial velocity is all the same, and their masses are all considered one. We're really getting a very, very uniform, almost like nucleus electron-like kind of pattern here. So this is just a beginning point. Now, let's think about what happens if we start to add multiple attractors. Actually, I want to vary this a little more before I do that. So one thing I would like to do is, I think I would like to give the magnitude of its initial velocity something that's a little bit more variable, just to sort of see. So this now is going to be quite a bit more variable. So the initial velocities, some of them are much stronger than the others. And I think just to look at it for right now, I want to be able to see the paths a bit more. So you can see here now everything is circling and being attracted. Okay, I don't know. I don't know if I actually like it. It's kind of a bit of a mess now. I almost liked it better when it was much more uniform. But what I would like to do now is add multiple attractors in multiple places and see how that works. So let's go back, first of all, to just a single particle and have the particle once again have very little alpha. And we can see here's my single particle being attracted to this particular attraction point. Now what I want to do is add an array of attractors. Okay, so I'm going to go to the sketch and I'm going to say attractors equals an array. And now I'm going to say also the same exact thing for the attractors. What I want to do is say attractors.push, create vector, and here I'm just going to give them a random location, random width, random height. Okay, so now here I want this exact loop, attractors.length, and I want to say attractors index I and attractors index I. So I just want to see, I'm going to comment out the particles for a second. I just want to see, does this get me a bunch of attractors on the screen? I missed. Attractor is not defined. Where attractors, S there. Okay. So I only see one. Did I? Oh, because I only made one. Let's make 10. Okay, so now you can see this is each time I refresh the page, I get a random assortment of these attractor dots at different spots. So now I want to see if I can have the particles accumulate their attraction to all of those points. Okay, so here, notice how I had particles. So what I could actually do here is when I'm looping through, there's so many different ways I could do this, but I'm actually just going to put this loop of the attractors inside the particle loop. There's a bunch of different ways you could do this. This needs to now be J. And I need to say attractors index J. Now, this actually isn't going to work, but this is the idea. There's a big problem here. So first let me draw all the attractors. Then for every particle, let me have the particle interface with all the attractors, then update and show itself. And if we do this, we should see here's a particle. Now it looks like it could be working. Kind of just left the window. Let me run it again. The issue is actually it's not being attracted to all of the attractors. It's being attracted to just the very last one. And let me show you what I mean by that. In the attracted function, here, I'm setting acceleration equal to that force. And the way that an object behaves in an environment where there are multiple forces is its resulting acceleration is the result of the sum of all of the forces at play. So you can't just say, set the acceleration to this attraction, set the acceleration to this attraction, to this one. I've just got the last one. I need to add them all together. This is known as force accumulation. So it's really as simple as me saying acceleration.add force. So this is going to, I'm back, is going to take over the other. Now, there's another issue here. The way that force accumulation works is at every moment in time, we start from no acceleration and add all the forces together. Then we move. Then we start over from no acceleration and add all the forces together, and then we move. The problem with this is I need to make sure that acceleration is cleared out to 0 every single time. And a quick way I can do that is once I'm done with updating, I can just multiply the acceleration vector times 0. Because if I take a vector and multiply its components by 0, it zeroes everything out. So that's a quick way that I can do that. Okay, so let's see what happens now. This is now, it's hard to sort of know exactly what's going on, but this particle is experiencing an attraction force to all of the other attraction points around. I wonder if we just had 2 attraction points, it'd be more clear, or if I started with a lot of particles. So let's go back to, let's keep that, let's take this out. Let's start all the particles at the same location. And actually, I think it might make sense to start all the particles in the center. And let's try to just do 10 particles and see what happens. Boy. Oh, look at this beautiful, amazing result. Yay, coding challenge done. This is not the result that I was hoping for by any means whatsoever. Let's see if we can. I might have a mistake in the code actually, because that's kind of a weird issue. So let's see if we can tune this to give us some. I mean, first of all, I could just refresh it, and we can see. I'm going to get different results each time. This is maybe a little bit more promising in a way. I also might. I might want to allow the. I think this constraint actually was kind of useful earlier, but I might like to let things get a little bit stronger or weaker, just to see sort of what happens there. It still probably needs some sort of constraint. What I actually probably could do is down to 1, down to something like this. So I think this might give us more what I was kind of hoping for. And now the question is, am I getting some, here's the thing. This is a very sort of basic idea. Camera went off. The forces are too weak for the faraway attractors. Yeah, so in the chat, I'm seeing the comment, the forces are too weak for the faraway attractors. So that certainly makes a big difference here. What I would like to actually see is a different way. I want to see this layer itself, much more kind of slowly over time. So a couple things. One is I would prefer not to actually draw the attractors. So let's not bother to draw the attractors. Let's go back to the particles. And one thing that I want to do is I want to create a vector that's its previous position. And then each time after it's drawn, I want to set this.previous.x equals this.pos.x. I want to save its last position. This.previous.y equals this.pos.y, because I think it might be nice to actually connect its previous location with a line. So right now you're noticing that I don't really see its path because the dots move, when it moves quickly, the dots are so far, and I mostly just have this mess. But if I connect it with lines, it's going to be a little bit more clear. I'm going to change the stroke weight to 1, and I'm going to give it a lot more alpha. And we'll see what sort of paths I get here. So you can see a bit more clearly what I've done is to kind of get these lines. So let's run for a little bit. So I'm going to let this run for a little bit, but what I want to do is also, I think thinking about how I do this constraint is probably, so that the forces are always at play, even if it's far away, is going to be kind of give it more of a dynamic quality. I could also do something where, you can see now I'm getting something more like what I was hoping to get, is some more regular kind of patterns. I guess with the alpha over, letting it run for a long time might be interesting and nice to watch, but I don't have the patience for it right now. So I'm going to go just back to the particle and draw it with a lot less alpha. And then one thing I want to do is let's go back to, I'm just curious what happens if I let the particles all start at a random location, but I actually just don't give them an initial velocity. Everything might settle into, that's kind of a nice pattern. Everything might settle into something of a regular pattern. And I'm going to do that by, I'm also going to, I'm going to constrain this a little bit more. And I'm going to also add 500 particles, which is probably going to make it run way too slow. Yeah. So this is more like what I was hoping to see. And now you can see it's too many particles and the alpha isn't enough. So let's lower that. And let's also lower the alpha a little bit more. And let's see what we get. So you can see here, I'm starting to get some patterns that might be a bit more regular. The constraint, really there's so much tuning that I really need to do to see if I can get some more regular patterns. I also, I'm kind of, sometimes I want them to be random, sometimes I don't. Let's have them, I just want to sort of see now back to the middle. Let's try like, this is, and then let's give them a little initial velocity. So let's try this. Oops, where did I miss? I missed something, I missed a parentheses. Okay, so yeah, so you can see that I'm going to get some interesting kind of regularish patterns just based on this, based on the kind of initial arrangement of the particle of those attractors themselves. And this is kind of what I was hoping to kind of see. Now, there's so much more you could do with this if you're more thoughtful about how you arrange the attractors, how you set the initial conditions. So many more possibilities here than just this. And actually, one thing that I might like to do here, just for the sake of argument, just to look at this in a slightly different way, is draw the background every frame, and now actually don't give them any alpha, and give them a stroke weight that's a bit stronger, and we can see, ooh, look at that. We can see, look at this as like a giant group of all these attractors like flying around and being attracted to different things. So this is also kind of interesting to see. And you can see I'm not putting any limits on the speed or any constraints. This is kind of what we're getting over time. Okay, so I hope I'm going to release this code. I think that those of you watching might think more thoughtfully about, number one, here's some things you could think about. How are you picking the initial locations of the attractors? Maybe you're using a regular pattern, putting them in some sort of grid, putting them in a spiral pattern. How are you picking the initial conditions of the particles? Do they all have an initial velocity? Do they all not have initial velocity? Do they all start in the center in a random location? Do they all start outside the canvas itself and start coming into the canvas? How are you putting constraints? Are you limiting their velocity? How are you scaling their the strength of the force based on their relationship with the attractors? So I think that what you could probably do is I've got the sort of building blocks here, but I haven't produced necessarily a result that I am particularly pleased with. But I imagine that lots of you watching this might come up with something different or interesting or exciting, and share it with me in the comments. Okay, thanks for watching this coding challenge of attraction particles. That's what Robot Girl in the chat says it would be neat to see what happens when particles die. I kind of want to go back. I'm going to cut out that whole end, and I'm going to redo that whole end, because I want to think about this some more. Color based on speed, because I would like to get a result that's a little bit more. So I think there's a couple things. So thank you for that. Thank you, Robot Girl, for that suggestion. Forget that whole ending to this video. I'm going to come back to, I'm going to play around with this outside of the video and then edit this back in. All these suggestions you guys are having are great. You should implement them, color based on speed. So, okay, so let's go back. Let me go back to what I had a second ago. So I want to see the paths. I think one thing that could be useful in the particle is to kind of limit how fast a particle can go. This is kind of interesting. I would like to see where the attractors are. I would also like to limit this strength maybe. Whoa, kind of interesting. What if I put the particles back in a random location? I could make some, I could make some attractors repellers. That's kind of interesting. It's really strangely stable. Like in finding some sort of like center point between all of the objects. So what also happens, I'm just curious, if I don't bother with this if I just have a completely uniform, whoops. What happens if I have a completely uniform, whoops, this computer keeps going away. Yeah, I should show the attractors. Didn't I not put that back in? Yeah. And let me just make these green. So what I want to do, I'm going to sort of come back to the video in a second, figuring out how to make this maybe produce more the result that I was expecting. What am I doing here? Why? I guess they really... I want them to, this is maybe more like what I was imagining. So this is now more like what I was imagining. I wanted them to cover more ground. And what did I do here that made that happen? Which is, and now if I... Yeah, this is more like what I was imagining that I was going to see. So what did I get here? This I just really, yeah, it's just about sort of tuning the, and now let me draw the trails. And let me go back to the particle and stroke weight 1 and 10. And this is, I kind of see what I get here with this. Yeah, it's kind of like I feel like I have this mistake in the code because it's like not really, it's as if they're only being attracted to the center almost as if they would normally be. Something seems off to me. And so let's double check everything here. Particle.attracted attractors J. And if I go into the particle, yeah, I'm accumulating them all together. So this looks right to me. Could you make it so you can place the attractors with the mouse? Great idea. Thank you, Cody. So what I'm going to do, this is perfect. Okay, so let me come back. So I'm going to do this as part of the tutorial video. So let me back up for a second. Okay, so hold on, let me back up for a second. Oh, I made the force so unbelievably strong. That was a problem. Okay, let me. Okay, so what I'm going to do, Mathieu, I'm sorry, I'm making this kind of a mess to edit back in, but I'm gonna work on. Okay, so this can get folded into at some point earlier before I started finishing the video. One thing that I think might help us tune this and figure out how to make it produce sort of visuals that we might like more is, let's see if we can actually position the attractors with the mouse. So what I'm going to do is just completely comment out the attractors. And I'm going to start this sketch. And you can see here are a bunch of particles all randomly positioned on the sketch. And I could even have 1,000 of them. You can see there's 1,000 particles randomly positioned on the sketch. But there's no attractors. Because once it gets to here, the length of the attractors is 0. So what I want to do is I'm going to add function mouse pressed. And I've also set the attractors now to be green to draw them so I could see them right here, which I just added that. a second ago that you didn't see because I edited that part out. Okay, but what I'm going to do is add. So I'm going to say attractors. Actually, I'm going to exactly what I had here, this line of code. But I'm going to say instead of at a random location, I'm going to add the mouse location. Okay, so let's see what happens now. So there's a lot of particles. And if I now click right here, we should see everything's attracted to that particular spot. Okay, so everything is coming in and zooming to that spot. Now, let me add another one here. And we should see now that everything is both attracted to both attractors. And I would expect to see something like a little bit of a figure 8 almost style pattern around both of them. And I could add another attractor over here and one up here and one up here. And what might be helpful here to see actually is for me to, just for right now, what I might like to do is put background and draw. So we can see now, these are very alpha-y, so I got to go back to the particle object and remove the alpha. And we can see now, the particles all being attracted to here, being attracted to, and what happens when I start to add multiple attractors. And even if I refresh, let me try to put them in a circle and see what we get. So here we can start to see a lot of interesting possibilities as these particles are attracted and they start to almost swim around in these different, and if we drew trails and thought about color, we would probably get interesting dynamics in terms of the kind of patterns that might be painted here in this surface. Now, I want to add something else. What I would like to do is think about what happens if these attractors are repulsive instead of if the particles are repelled by them rather than attracted to them. So what I'll do to do that really quickly is just right here in that attraction function, I am going to multiply the force by -1. And let's see what happens there. So I'm going to add repulsive force. Oh, let's add one over here. Now you can see quickly everything is just going to leave the window. So in that sense, not so exciting. Everything is just going to leave the window. What if, however, every other particle I click is, so when I click first, it's an attractor. Then when I click, it's a repeller. So I'm going to do that just by saying in this, I'm going to say if I modulus 2 equals 0, draw it as green, else draw it as red. So red for being a repeller. So we can see now as I click, I get green, red, green, red. Now they're all repellers right now, but the idea here is what I want to do is also change the direction of the force. So this is a goofy way. I should probably make, again, an attractor object that has a kind of weight to it. But I'm just going to pass in J right here to that attraction function. And I'm going to say if J modulus 2 does not equal 0, then multiply it by -1. Or if it equals 1 is another way of saying that. Equals 1. Then, so now, if I run this again, if I click, oops, we've got an error message. I made a mistake. J is not defined. Particle.js line 34. Oh, I need to add that as an argument here. So if I click here, we can see everything is now attracted to here. And then if I add this, it's repelled. If I add this, it's repelled. It's attracted, repelled, retracted. So we can sort of see, I should be more thoughtful about how I'm doing this. So one thing is, let's make this a little bit easier to see. With the particles, I'm going to make the particles have a stroke weight of 4, so you can see them more easily. And let me think, what if I put repulsion points around the edges and attraction points in the center? Oops, I lost track of what I was doing. So I don't know if I got anything interesting here, but you can see that you have a lot of possibilities for the dynamics of the system. Can you guys hear that? There's lots of loud talking in the hallway. Left click attractor, right click repulsor. Yeah, so there's lots of great suggestions in the chat. What I would encourage you to do is to implement, there's so many problems with what I've made here. So what I would encourage you to do is think about how are you adding attractors? How are you adding repellers? Where are they going? How are you adding the particles? What are the parameters of the particles? How fast can they go? How slow can they go? What's the strength of the various forces? And to see what types of dynamic systems and painting systems and patterns you could possibly generate from just a system of particles and attractors and repellers. The other thing that you might do is you might have an attractor, whoops, you might actually, do that again. The other thing that you might do is you might have an attractor where the particle is attracted to it, but once it gets to a certain distance to it, oh, I should just do this now, it's repelled. Let's try that for a second. So, for example, what if I go back and make them all, forget about this whole I and J thing. Let's just make them all attractors, so to speak. And then here in this attracted function, if you know what I'm going to do here just for a second? I'm just going to say force magnitude equals constraint. I'm going to make this 5. That mag squared, even though it's like a nice efficiency, it kind of confused me because I'm used to thinking distance not in terms of like squared. So this I think will be a little bit easier to sort of tune it. But what I want to do is say, if that distance value is less than, if the distance value, if it was within like 100 pixels, or maybe if it's within, let's say it's within 20 pixels, then force multiplied by -1. So now I have a particle that's always attracted, but when it gets close to the attractor, it actually is repelled. And so let's see here. Whoops. D squared is not defined. D times D. And so now you can see, whoa, did I do that? Okay, let's think about this. I might have done this in a weird place. I had them times -1 there, sorry. So, look at that, they get kind of like stuck right there. That's kind of interesting. That's pretty interesting. So what happens now if I add multiple ones though? There, whoa, whoa. This is kind of crazy. I don't have a lot of variation now. They're really like, that magnitude, I think, is so strong. Yeah, this is more what I expected. There we go. So this is kind of what I was looking for, is kind of an interesting system, I think, to think about. That they're repelled, but, and now what might be more interesting also is if I, what I'm going to do now is instead of adding the particles in setup, I'm just going to add particles. Here we go. This is what I meant to do all along. I'm going to add particles one at a time in draw. And what I'm going to do is also, I should give the particles a lifespan and have them eventually time out. There's too many possibilities here. I've lost my mind. So I think I'm going to leave it at this. And because I'm getting all sorts of weird behavior that I kind of like in an interesting way. But I think you, the viewer, you're creative, you're a designer, you're thoughtful. I've shown you a lot of possibilities here, and that I hope that you take this particular example, run with it, and create an interesting system of attraction and repulsion. By the way, everybody in the chat was shouting at me about this, and I didn't want to implement it because it adds a bunch of extra complications. But certainly, you know, I certainly have particles attracted to each other. So anyway, so here you go, particles and attractors coding challenge. I hope you enjoyed it, and please share with me what you make out of it. Okay. So order of operations. Oh my goodness. Wait a second, everybody. Pause. I have a major problem in this. Don't go away just yet. Yeah, this is like majorly wrong. Yeah, the force is much weaker. Hold on. This coding challenge has been a total disaster. And I thought, this is no problem because this is one I totally know how to do. Let's increase the strength here. Yeah. I've come back with an addendum here. It's all the same, but more slowly because the force. Yeah. And interestingly enough, if I take this idea out, yeah, the force gets so strong because this is so strong. I should let it get weaker. No. Boy, there's just so much tuning to do with this. I'm looking at the chat. If the attractiveness depends on the radius of the attractors. Yeah. Spawn new only if random value is greater than so many interesting ideas. Okay, I think I'm back. Okay, I'm back. The internet went out on this. Unfortunately, I'm streaming over Wi-Fi, which is really terrible because the Ethernet's not working in this room. I'm going to be back on Friday. I swear, Friday's going to go much better than this. Boy, it's almost 4 o'clock. Ooh. Okay. Let me try to see if I can salvage this coding challenge. I'm going to feel much better once people on the internet use this code to make actual interesting, beautiful things. Yes, thank you, Mathieu. I do need to do some sort of, I just wanted to get this to look. What's funny is I had a student have this beautiful homework assignment with attractors, and it looked so nice. I thought, oh, this is what I was planning to do last Friday, and the student did it as a homework assignment. It looked amazing. I thought, I'll just whip that up. Apparently, I can't do it. Okay, let me see if I can salvage this, because one thing is, okay, so I'm going to go back to where I was like here, and then realize there's an error. Okay. Oops. Chat pointed out a really big error, actually, that I just had, which is that in my particle object, I'm supposed to divide by distance squared, but this is actually g divided by d times the order of operations is off. This really needs parentheses around here, which is going to massively weaken that force. And you can see now the force is much, much weaker, but it's still kind of the same idea here. And then if I put another one, it's going to be attracted or repelled. So one thing I might do, kind of like amusingly, is like I could change and make the repulsion force much, much stronger, which you can see it's attracted, but when it gets within a certain distance, that repulsion force is really, really strong. And then I could also... And then that repulsion force is really, really strong. And then I could also sort of think about tuning the attraction force and figure out, and someone in the chat asked, by the way, shouldn't that constrain between 0? It could be, but I definitely don't ever want to divide by 0. So if I were really trying to be accurate about this, I would constrain it by like 0.0001. But I'm trying to just kind of tune it in a way that the force is... yeah, there you go. So now I made that repulsion force really, really strong. And you can see, I don't know what the point of what I'm doing is, but these things are attracted to all these different attraction spots, but they can't get close to them. And so you can see, and if I add another one right here, then I'm kind of creating these little pockets. That's kind of a nice little behavior. And you can sort of see what I've got here. I've got all this stuff trying to get attracted, but then being repelled when it's close. So I've gone off a little bit of the deep end here with this kind of attraction repulsion thing. And I think what would probably be more interesting, or no, I've said this a bunch of times, and now this video is being edited. I don't know where my head is at anymore, but let me wrap this up. So the tools that you have now from this example are the idea of calculating a force between two positions. So the attractors are fixed, but those could be particles that move. All particles could be attracted or repelled from all other particles. So that's something you could add to this. You could think about drawing trails with alpha and picking color, where you start the particles, the strength of the attractions, how you constrain that distance, whether it's stronger when it's closer, whether it's farther. So every parameter, every variable, everything that defines how these particles move could be something that you could tweak. And so I hope that you create some type of simulations or paintings or algorithmic. You know, what if you had an image and you kind of put attraction points all along the contours of the image and then fill that image with particles and then had those particles be the colors of the image? Could you paint a picture that way? Could you make an installation where the attraction particles are where the user's hand is? There's so many possibilities here. So I hope you make something with this and discover something interesting and make it and share it with me in the comments or on Twitter at Schiffman. If you have any complaints, please send them. I don't know where you should send them. Send them to me, I suppose. I can understand you having a lot of complaints after watching this particular video, but I'll see you in another episode of The Coding Train. Goodbye. Okay, yes, thank you, Alka. So 100%, I should really limit. You know, I should have the particles fade out. Let me at least put that in here. I can even do it at 100, so we can sort of see what I get here. Okay. All right. So get yourself a beer now. Thank you, Zombie Brains. No, I can't. I've got to salvage this somehow. Oh no, let me just check. I need to check my phone, which I put away. I put my phone in the corner somewhere. I just need to make sure that there are no heavier jackets, blah, 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 1 hour, blah, 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 blah. Okay, there's no emergency messages. There's a lot of people requesting that Google Doc. Oh my God. Okay. Okay. I think this is a terrible, terrible idea for me to attempt another coding challenge. Especially one that I have never actually looked at until this morning. But it just looks so nice. How hard could this be? R equals cosine k times theta for various values of k equals n divided by n. So if I do this and then convert to Cartesian coordinates, and if k is an integer, the curve will be rose-shaped with 2k petals if k is even and k petals if k is odd. Yeah, we should try this, right? Rose with 8 petals, k equals 4. Okay, I'm going to give this a try. Yes, dude, okay. All right, here we go. Okay, here we go, everybody. Let's get some motivation going in the form of, as always, I always forget the this dot, this dot, this dot, this dot. I'm going to do this dot. If it's 4:30 and I'm still here, I'm leaving. I cannot stay past 4:30. This dot, this dot, this dot, this dot, this dot. Never forget this. Little ginger tea. This dot, this dot, this dot, this dot, this dot. This dot, never forget this dot, this dot, this dot, this dot. I'm going to do this dot, this dot. Okay. I'm going to do this dot. Rose spells now. I'm going to do this dot, this dot. I'm going to do dot, this dot, this dot, this dot. I'm going to do this dot.
this dot. I'm gonna do this.
Where
dot,
am I?
this
Attraction,
dot,
repulsion.
This dot. I'm gonna do this dot. This dot. I'm gonna do this dot. This dot. This dot. This dot's on. This dot. This dot. This dot.
I really need some more music to play. Rose petals.
This dot.
Roses.
This dot. This dot. Never forget this dot. I'm gonna do this dot. This dot. This dot. This dot. The this
I need
dot
to raise
song.
this
Never
up.
forget the this dot.
It's too low.
Somebody composed that song for me.
What if this actually is going to be a one take? Yes, I'm going to do this as one take. It's going to be short. Where's my terminal window? It's going to be easy. And I'm going to run a server. I'm going here, and I'm going to close Attraction, repulsion, roses. Why is my phone buzzing all over the place again? And I'm going to window, sketch. Here we go. Okay, and now I'm going to go to the browser and hit refresh, and we should be good here. Why is my phone going crazy? Because people are still requesting to view that. What are you guys are making me crazy with that Google Doc thing. And I have notifications on my phone every time. Okay, I've got like what's going on over here? Got like a shadowing thing happening. I guess we're just gonna have to live with that. You know what? I can cut that out. I'm going to cut that out because that's bothering me. This is going to take time though. I'm using the old Python server because that's just the one that I have memorized. I don't have a good reason. Window, sorry. This is, I probably shouldn't do this. Show live and preview. Yes. And then now I'm going to go to here and crop. I'm just going to crop out that spot. Okay, cropped it out. Show window, show live. Show live. Okay, so that little noise left. Okay, okay. Here we go. Roses are red, violets are blue. I'm about to code something. How about you? Okay. Okay. Rose mathematics. Rose with K equals 7 petals. All right. So, here we go. Let's come over here and erase this. All right. Here we go. Let's press some camera buttons just in case. Checking the time, it is 4 p.m. I forgot to record the intro for the Attractor. Okay, thank you for that message. I'm gonna do that after I do the rose thing now. Whoops. Okay, that's fine, that's gonna be easy, it's gonna be fast. That's gonna be easy. Adam has a live server package, I know. Hydrate, that's the problem, I didn't bring my water. I don't know if this tea is really hydrating me. I think it's dehydrating me. Oh my God. Okay. 29 minutes I have, says Yoda. Friday's going to be great. We're going to throw all this away, but come back and do it all on Friday. It's going to be great. Okay, here we go. I'm tempted to do this. Hello, welcome to another Coding Train coding challenge. And in this challenge, whoa, this train is really loud. Can you please pull out of the station now? On the train are roses. Because one thing that I really like are flowers. And there's some wonderful mathematical algorithms that you can get to make these beautiful rose like patterns, and you can see even here all sorts of different possibilities. So I've been really interested in tiling and symmetry, and I'm hoping to do many more videos about different topics like that, and this is kind of along those lines. So this is actually something that I could do with just this incredibly simple formula where r equals cosine of k times theta. So what does that formula mean? We're going to have to figure that out first. So, oh, wrong button. Over here for a second. So here's the thing. The stuff that I'm going to code, which I have not done before, so hopefully it's going to work, is built entirely around this idea of polar coordinates. So if I have a Cartesian space, meaning a plane, a flat plane like this whiteboard, not a plane flying in the air, a plane like this whiteboard, and I have a point in the plane, you know, this is the same as I might have a point in a canvas. In all my videos and in computer graphics and in programming, we usually think of this point as an XY location. But actually, right, this is its X location, and this is its Y location. But another way, and this is known as a Cartesian coordinate, named for the French mathematician René Descartes. Okay, now how did I do, French viewers? Now, I just sounded like a completely ridiculous person. Now, you could also think of this point as a distance from the center known as r, radius or distance from the center, and an angle relative to the x-axis. This r comma theta is known as a polar coordinate. So here's the thing. Remember, you know those functions, sine and cosine? So, ka, toa. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Here's our triangle. Here's this angle. So, sine of the angle equals opposite, or y, divided by hypotenuse, or r. Cosine of the angle equals, x divided adjacent, which is x, over hypotenuse, which is r. I could write these in another way and say y equals r times sine of theta, and x equals r times cosine of theta. In other words, camera's over here, but I think you can still see me. In other words, I can think, my mind can think in terms of polar coordinates. I can calculate r's and calculate thetas and do all sorts of stuff. And yet I can draw something p5, or processing, whichever environment that I would use, only accepts in the ellipse function, and the point function, the vertex function, Cartesian coordinates. So this is a way of me converting from polar, which I'm going to think in, to Cartesian. So let's come back, and that's actually what I want to do here, is this idea is use this formula as a way of calculating a radius based on an angle. The radius, how far from the center, is going to be cosine times k some constant, and then this formula here is if this is r, x equals r times cosine of theta, y equals r times sine of theta. So we should be able to do this relatively quickly. I kind of wish that I was doing this in processing for some reason, but I'm doing it in p5. I'll make a processing version and post a link to that code in the description as well. Okay, so let's just say, for the sake of argument, that I'm going to write a loop, because I think this is probably the easiest way to do it for the moment. And I'm going to write a loop where I can't write 2 pi, where I have a variable called a, which starts at 0, goes all the way up to 2 pi, and I don't know, I'm going to increment by some arbitrary amount. I could be more thoughtful about how I do this. And so now, just to see that this works, I'm going to say var x equals, let's make up an r. Var r equals 100. Var x equals r times cosine of that angle. Var y equals r times sine of that angle. And now let's just draw a point. Stroke 255, where did that console.log come from? Stroke weight 4, and then point x comma y. Now here's the thing. This is all predicated on the notion of having these points around the point of origin. But the point of origin by default on the canvas is the top left. So actually, before I do any of this, I want to use translate to put that origin in the center. The top of this marker went down over here. I'm back. Okay, so now what I want to do is add translate to the center, which is width divided by 2, height divided by 2. And then let's see what we get. There we go. So you can see, look, I got a circle. So something's working correctly here. And you can see here if I say go up by 0.1, we can see, I'm drawing all these little points. This is just a simple demonstration of polar to Cartesian transformation. But now, let's go back and let's go back to that Wikipedia page and let's try k equals 7. Let's try k equals 7. So r equals cosine of k times theta, or the angle, that is. My variable is a. So r equals cosine of 7 times a. Now let's try this. Hey, what happened there? So I wonder if I need to really expand things out, or I just need to quit. There we go. So I just need to expand things out. Now, what I might want to do now is have a bit more gradation. And so I can start to see this pattern forming. And what I can actually do that would make more sense now is for me to say begin shape, end shape. Forget about the stroke weight, or just make the stroke weight 1 and set these as vertices. So what this does, instead of drawing a dot at every spot, I'm saying begin a shape, end a shape, and connect everything. And then maybe at the end I'm going to say close. And we can see, there we go. Look at my beautiful rows pattern. So in a way, we're done. That was like the quickest coding challenge with no editing whatsoever. That never happens. But let's make this worse. I should just quit while I'm ahead. It's like, that was like 8 minutes or something. Less than that even. Let's see what we can do. So let's just try some of these other, let's try k equals 4. And I should probably make this, let's make this a kind of global variable for right now. I'll just put it here in draw. K. Actually, what I really should do is make that something that I adjust with a slider. Oh my goodness, that's crazy. So let me say k equals 4 and change this to k. Whoops, in the wrong place. We can see, there we go, with k equals 4. And if I go back to here, now, rows curves defined by r equals cosine k theta for various values of k equals n divided by d. So look at this, n divided by d. So what I want to try, I want one of these. Like, which one do we like? I like this one. So 5 divided by 8. So let's try 5 divided by 8. Ooh, something went wrong there. Let's see here. K for various values of, what did I, 1, 5 divided by, n divided by d. We better open that chat. This is gonna, time to, yeah, we're gonna have this tau fight again. What did I do wrong here? I shouldn't have, I told you I should have quit while I was ahead. 1, 2, 3, 4, 5, 6, 7. Let's try 0.5. So let's do, hold on. I'm now in a moment where I don't want, yeah, something went wrong here. K times A, does this, like, yeah. Yeah, this is interesting. I don't know what, like 6 divided by 3 is 2. 5 divided by 4, let's try that. What am I, anybody see what I'm missing? Yeah, I wonder if I have to go around more times. So that's the problem. It's more loops. Yeah. Okay, how do I, okay, let's go backwards in time. I'm going to pretend to have the same problem again. I don't remember where I should. Yeah. Where was I? Where did I last leave off? There. There. All right. Let me come back. Put k equals 10 and r equals 200 times k times a. Yeah, 10 times 2 pi. Okay. There are no integers in JavaScript, only floats. Yeah. Okay. I don't remember where I was, but I'm going to come back, try to go back to this, and Mathieu will figure it out. Okay, let's try some of these patterns. So for example, I like this one, which is like 5 with k equal, you can see this, k equals n divided by d, and this is a table, 5 divided by 6, or 5 divided by 8. Let's try one of those. So if I come back into the code and I make, I have a variable called k. Did I have that already? Shoot. Let me come back, hold on. So let me come back into the code and add a variable called k, and actually just put k down here. And then what I can do is, so this should be the same for, one thing I want to do is get rid of the fill, just so I can see it like this. And then what I want to do, is change this to, what did I say it was? 5 divided by 8. Okay, so this I think is right. And I had a problem with this. And I think the issue is that I need to now go around the loop multiple times. So I wonder if there's a way to calculate that exactly, but I'm just going to multiply this by 10. And we can see, there we go. So if I go around the loop multiple times, we get this beautiful, nice tiling pattern. Maybe I went too many times. I'm not sure what this extra line is doing here. It's like connecting back to the center. So I'm sure I could clean this up in some ways. But I think what would be interesting to see right now, very quickly, is if I add the DOM library, and if I say var slider, slider equals create slider, and let's give a range between 1 and 10, starting with 4, and increment rate of 0.1. What I should see is now I can say k equals slider.value. Now let's give this a try. So now as I change the slider, we can sort of see different possible shapes and possibilities as I move it around. Now I might need to adjust how many times I'm going around in the loop based on the value of the slider, as you can see. And I think you need, Alka in the chat writes, I think you need D loops. What is D? Oh, D is, or D times 2 pi, but what is D? I'm waiting for Alka. Alka is typing. Oh, n divided by d. Thank you. Okay. So right, that makes sense. So in this case, hold on. Because all right, edit this part out. So anyway, so I think there's probably a precise way you could calculate. You could calculate how many loops you need. Alka in the chat suggests, actually, like looking at this, that you need, depending on what this d value is, the denominator of this frac, that's how many times you need to go around the loop, which makes a lot of sense, actually, because how you're multiplying by pi, you don't need to hit all the sort of angles to get all the positions. But anyway, so we could sort of test that. I'm going to take the slider out just for a second and say multiply by the denominator value, and we can see, yeah, there we go. Now that's perfect. So that's definitely right that you need D loops. And so we could change this to be, oh, this is exciting. Because what we could do actually have two sliders. We could say D, the denominator is 8. The numerator is 5. And I could say slider D, slider N. Slider D equals some value between 0, 1, and 10, starting at 5. And slider N, some value between 1 and 10, starting at 5. And then I could say here, D equals slider D's value, N equals slider N value, and I could say K equals D, numerator divided by denominator, and then I could keep d right here, and k is here. And I think now we would have, yeah, you can see here the different types of patterns I'm getting, which I think are correct and probably match. Now, it would be nice for me to report. It would be nice for me to actually report what those values are and then double check them. But I think this is Rose mathematics pedal stuff. So how can you maybe, play with this, create a whole bunch of them, have it morph from one to the other, fill it with colors, tile them all next in a pattern. I'm sure there are a lot of possibilities. Yeah, I should probably make the step size smaller, which would also give me maybe a more fluid. Alka in the chat is giving me lots of great suggestions. Give me a more fluid view of this. And we can see, oh, look at this. Ooh, we're going to get some weird funny business here for strange decimal numbers. But you can sort of see one, and I have to clean up this thing where it ends, doesn't end back at the beginning. So anyway, so there are a lot of wonderful possibilities here. I hope you enjoyed this Rose Mathematics Challenge. I hope you make some stuff with it, share it with me, and I would love to see the world filled with flowers. That's what my dream is, or at least computational flowers. So make some GIFs, make some images, tweet them, share them with me at Schiffman, and I'll see you. And the next train is leaving the station. It's the close I could probably end. So, all right, that was great. That actually happened rather quickly. It's 4:18. I got to go back and do the intro to the horrific Attractors challenge that I want to delete from the internet. So let me run the server and make a, I guess I'll just leave this up here and minimize all this stuff. So what I want to do is, I'm going to just look for, hold on. And of course, my Google search shows up with me. Yeah, this is what I was looking for. What are these? Who is this from? Okay. So this is kind of like more like what I was imagining. Like this, complexification.net. This is kind of like the images I was imagining. Visit page. Yes. This is Jared Tarbell. This is what I was kind of imagining getting. And I guess there's a lot more. Oh, no, this is a different thing. This is not using gravitational attraction. I really got to go. But so I think I'm going to just leave. This is so funny how I show up in these Google searches I'm trying. This is kind of what I'm looking at. This, Richard Marxer, design, computation, recursion. Anyway, I'm just going to leave this image search up. And then I'm going to pull this out. And, okay. Let me move this over a little bit. Okay. Okay, here we go. I am going to, the shapes need to be open instead of closed. Yeah, that would fix that problem. Okay, I'm going to record a quick intro to the Attractor challenge. I'm going to just I'm minimizing that laptop. Is that actually a term? Then I've really got to run. Okay. Hello and welcome to a coding challenge. So this coding challenge is called, I think, Attraction and Repulsion. So I'm recording the intro after I did the challenge. It was kind of a mess, and I never really got to the result that I wanted, and I just sort of played around with a bunch of different possibilities. So I'm asking you, the internet, to, are you the internet? I'm not sure who the internet is. Maybe it's you. I don't know who it is, but you're watching, to take my code and hopefully expand on it and improve on it in interesting ways. So what I was imagining was creating a lot of interesting attraction patterns by looking at the the trails of various objects as they move and get attracted to different attraction points within a canvas. And you can see if I just kind of Google image search attractors and processing, we're seeing a lot of visual images like this. So you can imagine dropping a whole lot of particles into a space, ignore this image of me behind me, and having them sort of swarm around and move around all of these invisible attraction points. So where I got to with the challenge is kind of an end result that looks something like this. And what I actually started doing was just showing in the challenge towards the end, I decided to show you the difference between attraction and repulsion. And if I add a bunch of these all around, you can see what's happening is every single one of these attractor spots attracts these particles that are just entering the scene, but when they get within a certain number of pixels of the attractor, then they're repelled with a very strong force. So this hasn't really produced a visual result necessarily that I'm happy with. I would be interested in what happens if I looked at the alpha blended trails over time, but this example that I end with should have all of the pieces for you to take and add your own design, creative spin on it. So watch the video, you'll learn a bit about how vectors work, how forces work, how you can add different objects with the mouse, with arrays, and looking at how you can accumulate different forces and have interplay between different particles moving around the screen. And the mechanics of it will be there in the video. I'll make lots of mistakes and get confused. And then at the end, you'll look at this video's description, find the code, and hopefully expand on it and make something much more beautiful and much more interesting, because I really failed at doing that. So I hope you enjoy this coding challenge. I guess I have to, at this point, I have to blow the train whistle. It's like I have a contract, which doesn't exist, but it says in there, blow the train whistle. So that's what I've done. Enjoy the coding challenge, and maybe you'll still be watching at the end or in the next video, or you might run away forever and never come back, which I would totally understand. But anyway, goodbye. See you soon. Okay. All right, everybody. It is 4:23. I have definitely got to go. I hope that today was illuminating and useful in some way. I will be back. The regular time for Coding Train episodes will always be every Friday around 10:30 a.m. Eastern Time. Sometimes I will do a bonus live stream. I'll do once a week. Sometimes I'll pop in for an extra bonus one like I did today, especially if I miss a Friday. I wouldn't be surprised if I end up missing more Fridays than I planned for, because that's why I was never able to establish a regular time, because the schedule is different every week. But I'm really trying to do that. So hopefully come back this Friday. I'll see you Friday morning. Tweet me at Schiffman if you liked today, if you didn't like today. I'll always love to hear feedback. And the live stream archive will get published. The edited versions of the videos will get published over the course of the week. You can support me if you like this stuff on Patreon. I have a community there now that has a separate chat. I'm able to look at the Patreon chat a bit more during the live streams, and all that sort of stuff. I'm trying to think. Great, I'm seeing some very nice, friendly comments in the chat. Usually I like to just pick some random questions from the YouTube chat and try to answer them, but I have to go pick up. I don't need an intro to the Rose Mathematics one, because I feel like I did the intro in the video. I didn't need to go back and do it. I have to go pick up children from puppets class and sing and dance class, and I can't be late to do that. So yes, and I will tweet and all that sort of stuff when the code is available and on GitHub, which I'll try to do later tonight or tomorrow afternoon sometime. Okay, goodbye everybody. I will play you some music. I guess everybody's song seems to be the This Dot song. Anybody out there who wants to make me some more music? By the way, there's this great podcast called Rarefied Air from Adam Blau, and it goes through all these catalogs of TV music from the 80s. And you could license that stuff, and I want to license that stuff, but I just haven't had time to look into that. So this is my goodbye song. Okay. I'm going to start turning off the lights. I like this to be part of the stream, right? You can kind of see what happens. I'm going to turn off this light. It's getting darker. I'm going to turn off this light. It's even darker. I'm coming back over here. The keying is about to get not so good. Oh, how do I turn? Where's the button? That light is off. Darkness descends. I'm going to turn off this camera. That camera's off. I'm going to hit stop on the record. And that's it. I'm looking at the chat. And this dot. Okay, everybody, how much longer does this song have? Oh, it still has a minute and a half. I just sort of like, we should all quiet down. The thing is I gotta like turn off the microphone, but then I can't talk anymore. So I'm gonna do that. You know what I could do? I can still be streaming when I do this part. I'll leave the microphone on for a second, just taking it off. It's kind of amazing that the quality's not so bad even without the lights on. So I'm gonna turn off the record, and then I'm going to Google Drive, where I do a backup of all my recordings. What is today's date? It's like February 7th. February 7th. And if I go to the desktop and 1080p test, these are from today. I have a bunch of different video files. I don't know which ones. February 7th. February 7th. So those should be uploading now to Google Drive. So I have backups of them. And you hear the mouse clicks? Yes. Are they really loud? I took the code. I'll try to get it up later tonight. Okay. 16 seconds left. Oh, there's more. I timed it so perfectly. Okay, goodbye everybody, and I'll see you on Friday or another time if I change the time. Okay, goodbye.